an introduction to the name of my talk, and I gave a quick introduction around kind of what it's about. But just to reintroduce, this is Transforming GraphQL, Full Stack Infrastructure as Code. This talk is going to be broken up into 4 different parts. We're going to do an introduction into Amplify and into the GraphQL Transform library. We're going to then look at doing data modeling using the GraphQL Transform library with the GraphQL schema. Then I'm going to do some rapid prototyping. And I'm going to basically start from scratch with a new API, and we're going to build out a real backend. And we're going to do that, rapidly, quickly, hopefully. And then we're going to go into a couple of live examples of some apps that I've built using this library. And then after that, I'm actually going to extend the prototype that I've built to add a couple of additional pieces of functionality if we have the time. So I'll do an introduction again to myself. My name is Nader Dabit. I'm a software engineer that is currently working as a developer advocate on the AWS Amplify team. I'm also very involved in a lot of open source. So one of the first libraries I created was React Native Elements. And since then, I've created a lot of stuff now with Amplify, full stack, blueprints, I guess, or reference architectures and things like that. I've also written a couple of books, and my most recent book is called Full Stack Serverless, and it applies a lot of the stuff I'm going to be talking about today, and shows how to kind of build out these full stack applications, more specifically with the React framework. So the team that I work on is a team within AWS called the Amplify team. And our main focus is really around building full stack tooling and SDKs and libraries for full stack cloud applications. And a lot of the developers, like I mentioned, on my team are actually from a front-end background. So we have kind of a lot of the same experience in the past, and we bring a lot of that knowledge and a lot of that experience to the team. Whereas I think a lot of the teams in AWS are more back-end focused. Because we're not only building tooling for the back-end, we're also building SDKs and libraries for the front end. We're able to kind of take a lot of the experiences that we've had in the past and hopefully build a better developer experience. So what are some of the companies that are kind of building with AWS at the moment? Really the big companies, any of the big companies that you can think of for the most part are possibly using AWS. Here are a few examples: Airbnb, Netflix, Nike, and of course Amazon. And a lot of the actual services that we use in Amplify are the same ones that these companies are using. But in the past, it was kind of hard for a developer that wasn't really a specialized cloud developer to kind of take advantage of a lot of this stuff and do so competently. So when I say full stack cloud tooling and SDKs, what exactly does that mean? Well, I'm going to break it apart as far as Amplify is concerned, first of all. So Amplify is a combination of 3 main parts. First of all, we have a static hosting service that allows you to either upload a folder or connect to Git, or a bunch of different ways you can kind of deploy with just a couple of clicks. And then on the actual application development side, we have a command line interface, a CLI. And the CLI is the main thing that we're going to be kind of focusing on today, really. And it allows you to create and configure and update cloud services directly from your front-end environment. And for instance, let's say you need authentication, you can add an authentication service using the CLI. And then once you actually deployed whatever services that you'd like to create and updated those, then use the Amplify client libraries to then interact with those services. So let's say you're writing a React application and you've created this authentication service. How do you actually make API calls against that authentication service? Well, we provide those client libraries that kind of make that pretty easy. So let's take a look at the CLI. The CLI workflow looks something like this. You, of course, need to install the Amplify binary globally. And then from then, you can run commands like init, add, push, and update. Init would be just creating a new Amplify project from scratch. Add would be adding a new feature. Update will be updating a feature, and push is just pushing the updates to your account. And what's actually going on under the hood is pretty interesting, because again, when I mentioned full stack, we're talking about we're building out not only server-side code, but also client-side code a lot of times. So when you deploy a new Amplify app, you have something that's known as a cloud, or called a CloudFormation stack. And this is something that is really abstracted away for you, but essentially what it's doing is it's creating that base project in AWS that you can then add features to. And then once you've created your project with Amplify init and you run Amplify add, you're then creating new services that are being added to that CloudFormation stack. And that is all done, in the back end. Now, as far as the front end, you're going to then have two artifacts. One is going to be an Amplify folder that we're going to take a look at kind of in just a moment. And this has all of the code that you would create and update locally. So for instance, let's say you create a GraphQL API, the Amplify folder would hold the GraphQL schema. And then we also have a local configuration file, just a single file that's kind of like a key value pair for all of the services that you've created. Now, all of this stuff is really managed for you by the CLI. You don't really have to know what's going on here as far as like changing it. The only thing you might be updating is that GraphQL schema and stuff like that in the Amplify folder, but it's kind of good to know what's actually going on under the hood. And then after you've, let's say, created those services, you can then use the AWS Amplify client. So here we're importing the API category from Amplify. And API category allows you to interact with two types of APIs. You can interact with a GraphQL API. So there's a GraphQL client for making queries, mutations, and subscriptions and stuff like that. And then you can also interact with REST APIs. So you can call get, put, post, delete, any of the HTTP verbs that you would like to use as kind of all part of that API category. There's about a little over a half dozen or so, or closer to a dozen different APIs. So we're just going to take a look at a couple of them. Another one that's pretty popular is storage. So if you're looking to store videos, images, and stuff like that, we have the storage category. Now, back to the CLI though, when we're talking about full stack, we're actually creating resources on the back end and we're creating resources on the front end. And the cloud infrastructure is the thing that we're going to be kind of focusing on here and how that cloud infrastructure is created. And when I say infrastructure as code, what we're essentially doing under the hood is creating that infrastructure as code for you from the CLI. Now, what is infrastructure as code? Well, infrastructure as code is essentially like some type of configuration file describing the cloud resources that you want. So let's say you wanted to have a database and an API and a Lambda function to maybe kind of glue all that stuff together. If you were writing this infrastructure as code from scratch, you would have this big configuration file and you would need to know the key value pairs. You would need to know all of the different resource names and how it all works together to make this work. But someone that isn't a cloud engineer isn't going to understand how to do all that stuff. But not only that, but it's very verbose. Even if you know what you're doing, a lot of it is kind of repetitive and it's kind of, there are better abstractions that can be done. And that's kind of what we're trying to do with the CLI. We're basically walking you through these steps. We're asking you questions, and then we're generating that infrastructure as code for you without you having to kind of like go in and make all of those tedious updates yourself. And then on the client, we're also generating different types of code for you. So I talked about those configuration files, but let's say you're creating a GraphQL API and you need your mutation, query, and subscription definitions created. We'll actually introspect your GraphQL schema and generate all that client-side code for you. So the CLI is doing kind of all of this stuff for you under the hood. So what are some of the categories that we support at the moment? All these categories are currently supported, and within these categories, there are multiple different features that you can use. So for instance, if you look at the API category, you can create a few different types of APIs. You can create a Go API, a Python REST API. You can create, a Node.js Express server as an API. You can create a GraphQL server. If you look at something like predictions, there's about a half dozen different types of machine learning services that you can interact with. So when you look at these categories, these 6 categories actually translate to a few dozen different types of features you can add. And underneath the hood, some of the services that we're using are API Gateway, S3, AppSync, which is a managed GraphQL service, DynamoDB, which is a really highly scalable database, infinitely scalable. A bunch of different services are kind of being used under the hood. But again, they're kind of being abstracted away into these category names. So you're kind of mainly working with the functionality itself versus the actual service name. As far as the machine learning services that we support, Poly, Lex, Translate, Transcribe, Recognition, a bunch of different stuff. You essentially are going to be passing either text or images into these services, and then adding a little bit of configuration like key value pairs and a JSON object or some type of object actually. And then you're going to be getting some type of JSON response back. So these are, again, kind of managed services. But really the thing that we're going to be focusing on with the GraphQL Transform library is kind of the tooling that goes along with the CLI. So what is the GraphQL Transform library? Well, I mentioned a little bit earlier how you take these directives and you add them to your GraphQL schema. But really what's going on when you do this and then you kind of run these builds that are happening either when you push or you mock the API locally is we're taking your GraphQL schema and we're introspecting that, and we're then generating the infrastructure as code based on your GraphQL schema. Now, we're going to demo this and talk, and hopefully you'll have a better understanding of it once we do that. But before we get to that point, like, why would you even need something like this? Well, the main part that you're going to run into, or the main thing you're going to probably run into when you start building out anything that's more complex than like your Hello World type of project, is you're going to start running into complexity. And you're also going to start running into edge cases and things that you're going to need to take into consideration for anything that is actually production ready. So let's fall back into what a GraphQL API is and what is involved in creating a GraphQL API if we're going to do this, like, say, from scratch. Well, first of all, let's break a GraphQL API into its main parts. You have your schema, which is the definition of all the different types, all the different GraphQL operations that you need for your app. So let's say we're creating a to-do app. You're going to need a to-do type. You're also going to need mutations for creating, updating, and deleting a to-do. You're also going to need queries for querying a to-do by ID, probably, maybe querying a list of to-dos, maybe even querying to-dos by some other field, right? So you're going to need all those operations. Then you're going to need to have some type of data source that stores these to-dos. So that could be a database or whatever, MongoDB, whatever you're using. And then you're going to need the resolvers that map between your schema and your data sources. So let's say you have this mutation for creating a to-do. Then you have your data source that's going to hold that data. Like, the glue between those two is that resolver. So you need to write that resolver code that kind of maps between the operation definition and the database. Now, in addition to that, that's just the core thing that you need to get an API up and running. You then have to take this and you have to host it somewhere. You have to host your data source as well. So you need to host your GraphQL server and your data source. And then also, when you start actually building this out, you're going to start realizing you need to take things into consideration around authentication, authorization, and security. So when you have a GraphQL API, you're going to have to think about limiting things like malicious queries. You're going to have to think about things like, what if a user trying to access this database or this API is not authorized? What if someone's doing some type of DDoS attack? You have to take all these things into consideration. Now, building this, like, from end to end is actually quite a bit of work. But the idea behind not only AppSync, which is a managed GraphQL service, but really around all of the managed services that you're probably ever used in your life that are being really taken advantage of now in this new era of cloud computing, is like, why would you build all this from scratch and kind of have to understand all these different things? And then, and in addition to this, you're building all this other stuff in your app and all these other services. When you're working with a managed service, you basically have a team that specializes in this one thing, and that's all they do for years at a time. And they've actually, taken all these things into consideration and, like, built it into the service. So when you think about things like Auth0 for authentication, you think about things like Cloudinary, you think about things like, like AppSync or whatever other managed services, S3, for example, you're basically trading all of this additional work to pay for something that someone else has kind of built as a service. Now, that's interesting, but what's even more interesting is that a lot of these services are now being priced and tiered as serverless options, which essentially means you're not paying for anything until you get a bunch of users. So the trade-off to me is always like, okay, if you can kind of have something that works really well that someone's already built, why would you rebuild it from scratch? Now, that's kind of the idea behind a managed service in AppSync in particular. But in addition to kind of like getting all this to work together, like, how do you actually add this functionality into your API? So let's say that you need rules around authentication and authorization, for example. You only want maybe the person that created it to be able to make updates. How do you write that functionality? That's really where the GraphQL Transform library comes into place. It's taking this managed GraphQL API and it's allowing you to add all these additional features to it using these transforms. So the workflow is something like this. You create your GraphQL schema, you add your directives there, and then in the build process, which is either when you're deploying or when you're running a local mock of your API, we're building out this CloudFormation or this infrastructure as code for you kind of under the hood. Now, what are some of the different transformers and the different types of functionality that you can add with this? The ones that we're going to be going over today are @model, @auth, @connection, and @function, I believe. But these are all the ones that you can kind of work with, and we're going to kind of go over some of these in a little more detail here. So @model is kind of like a core directive, and what this does, it allows you to take your base type and scaffold out a CRUD and list API based on that type. So let's say, for instance, we have this product type. Just adding this @model directive is going to add your additional CRUD resolvers. It's going to add, it's going to add the additional CRUD schema definition. It's going to add the resolvers for those additional schema, and it's going to add a product table. So just this 4 lines or 5 lines of code here is going to give us a product type. It's going to give us create, read, update, delete, and list products. It's going to give us subscriptions for on create, on update, and on delete. It's also going to create a product table and all of the resolvers for all those operations. And what you would probably then do, you would then add additional directives for additional functionality, or if you have like your own business logic, you might go into those resolvers and kind of modify them from there. Yeah, so that's kind of what you get. You get that CRUD plus list schema, you get the DynamoDB table, and you get the resolvers. Another one that's quite powerful is adding authorization rules with @auth. So let's say we only wanted the owner of the post to be able to make updates, deletes, or even read it. We could add this one line here where we're saying only allow the owner, but you can also pass in an array of different rules. So let's say a more common use case is we have a blog, something like Medium, and you want only the owner to be able to make updates, but you want anyone to be able to read. Using this combination of 2 rules, we have allow owner, which gives the owner full access, and then we have a public access that allows anyone to just read. Now, if you're public, you can't make any modifications, which is exactly what you probably want in something like Twitter or Facebook or even Medium or something like that. So you can add these rules, and you can add additional ones. So let's say, for example, you might want some type of admin privileges. You can actually add admin groups and stuff like that. So that's @auth. There's also the @function, and this is a transformer that allows you to define a Lambda function as a resolver for any query or mutation. So let's say in this example, it's pretty basic, but we're going to try to build this one out later. Let's say we have a Lambda function that's going to take in 2 numbers, number 1 and number 2, and it's just going to return the value of those 2 put together. That's kind of going to be a really basic demo. Well, you could add a query, something like this, where you have the 2 arguments, number 1 and number 2, return an integer. And then to reference any function in your app, you just use the @function directive and pass in the name of the function. Another one that's pretty powerful is for modeling additional data access patterns. So it's using this @key directive. So let's take this base type of inventory. As it is, we're only going to be able to query inventory by ID or to get all of the inventory, but we probably want additional access patterns. And in this example, let's say we wanted to query inventory by the warehouse ID. So we wanted to say, okay, let's go in our database and we want to get all the inventory, but only for this warehouse. We could add this key configuration where we set a key name, the field that we'd like to query, and then the actual query that we're going to be using in GraphQL, which will be the items by warehouse ID. And you can add as many keys as you'd like. So you can add dozens of different data access patterns using the @key directive. And then the last one, pretty cool, pretty powerful for people that are integrating GraphQL as an API gateway is using the @HTTP resolver. And this essentially just allows you to bring in existing REST APIs as a GraphQL query or mutation. So in this example, we're just saying we want this query to map to this endpoint. And then therefore we can call the list post query. And instead of mapping to a local database, we're just going to be mapping to that HTTP endpoint. So that's kind of the intro. But for this talk, I'm going to propose that we build out an API that has all the schema we would need for some type of API. We also want the resolvers to be mapped out based on that schema. We want the databases, so we'll probably create a couple databases. We want relationships between the different types. So let's say we have a post type and an author type or something like that. How would you model a one-to-many or many-to-one relationship or a many-to-many relationship between posts and authors? And then we want to define auth rules. So we want to be able to say, okay, only a certain type of person should be able to do certain things, right? Okay, so let's go ahead and try this out. So we're going to go ahead and demo this. And I'm starting off here in an Amplify project. And all I've done so far is initialize an Amplify app and added authentication. What we want to do now is we're going to go ahead and add an API. And this should be able to go ahead and walk us through the steps of adding a GraphQL API. So we'll call this API TINEL. We'll choose a default authorization type of, let's say, Amazon Cognito user pool. This is the managed authentication service that Amplify uses. You could also choose OpenID Connect for something like Auth0 or Okta. API key is basically public authorization. But Amazon Cognito is something like Auth0 if you've ever used that. For advanced settings, we'll go ahead and choose yes, and then we'll add an additional auth type. So we can have now multiple auth types. We're going to choose API key. And we're going to go ahead and say no to having an annotated GraphQL schema. If we did have one, we could reference that here, but we don't. And we'll choose yes to guided schema creation because this is going to give us a few different boilerplates that we can start off with. And I'll just start off with this single object with fields. And what's going to happen is this should open up in our text editor a basic GraphQL schema. That we're going to start off with. And this is basically just like a to-do type. But what we would like to do is maybe turn this into a different type of app. So I've done a few different types of apps. I think, one of the things that I've done is maybe like a post type. And the post is going to basically be like a blog post, and then we'll have a comment type. And what we might want to do is for the post type, we might want to have like a name. And to make this pretty simple, let's just do an ID and a name, and then we might have some comments. And this comment is going to be an array of comment. And then for the comment, we're going to just have something like a message. Okay. So here we have a post type and a comment type. What we want to do now is we want to add a few different things. We want to be able to add, first of all, we need to be able to associate a comment with a post. So we need to have some one-to-many relationship here. To do that, we can just add the @connection, and this is going to automatically map the comments to a post. So therefore, we can specify the post comment, the post ID of the comment. And then when we query our post, we can also query the associated comments. The next thing we might want to do is we might only want to allow some certain auth rules for a post. So let's say we only want the owner to be able to the owner to be able to maybe update or delete their own posts. We can just add this allow owner. But we also want to be able to allow anyone to be able to read posts, but the operations only need to be for read. So this is basically saying if someone isn't signed in, they can read the posts. If the owner created the post, they can not only read, but they can update and delete. And then we also want to be able to say, we want to say maybe if someone is signed in, which means that they have a private access, but they are not the owner of the post, we also want to allow them to read the post. And we can maybe go down to comments and think about how this is going to work as well. We might want to allow the owner to be able to update and delete their own comments, the public to be able to read comments, and then anyone signed in to be able to read. Okay. So we've modeled the post type, the comment type. We have the @model directive, which is going to add all of the different create, read, update, delete, and subscription definitions for us as well. And then we have some authorization rules around the posts and the comments. Okay, I think that makes sense. So let's go back to our CLI. And if your schema is valid, you should have some notification that it's compiled successfully. And if we go back now to our code, go ahead and open this up in a text editor. You're going to notice in our Amplify folder, in our API folder, we're going to now have a build that's going to have our expanded GraphQL schema. That's going to have not only the post and comment type, but it's going to also have a bunch of mutation definitions for us, a bunch of subscription definitions, and stuff like that. So basically, we've introspected. We've used that @model directive, and we've expanded the schema based on those directives. And this is kind of the base schema that we start off with. Okay, so what we can do now is we can do a couple of things. We can deploy this. So to do that, I can run amplify push. And we're going to go ahead and deploy this API. And it's going to actually now walk us through a couple of other things, because it's going to see that we're deploying a GraphQL API, and it's going to assume that we might want some local GraphQL code gen. So if we're going to be calling this API from a JavaScript application, it's going to allow us to create those operations in either TypeScript, Flow, or JavaScript. So I can choose the language target as JavaScript. You can just take the default for the rest of this stuff, and that's going to deploy that. But let's say we wanted to test this out locally before we deploy that. We can actually run Amplify mock and run a local GraphQL server, but we're also gonna mock the authorization, authentication, and databases, all that stuff locally. So when we run Amplify mock, it's going to introspect our schema. It's going to create a post table and a comment table. It's going to also allow us to do this code generation. And it's going to go ahead and open a mock endpoint up on our local host. So I should be able to go ahead and open this URL. And all else doesn't fail, this should mock locally. The endpoint is there. It's just taking a second to load. I'm not sure what's going on. Let me open up another terminal and see if I have other stuff running. Could be hurting this. The only thing I can think of is that because we're deploying, it's not able to kind of mock locally. So let's wait for this to finish deploying, and then we'll try that mock endpoint out when this deployment is not happening. And if that still doesn't work, we can always test this out in the actual service itself. So I'm going to go back to the slide deck, and we'll come back to this once it's been done deploying. But what you're seeing right here is actually the resources that we just created, the ones that are essentially in this Amplify/API backend folder. This is our infrastructure as code. And this build is actually being deployed right now. And that's kind of like the steps that we're seeing right there. But the next thing I want to do then, while that is happening, is show you a couple of examples of some apps that we've built using, or that I've built using this. The first one is a really highly scalable voting app that when I put the back end together, this whole back end took about an hour to kind of put together. And then after I deployed this, the actual service itself, we tried to kind of tear it down or break it. We tried to break it down by hammering it with as many operations as we possibly could, because someone had mentioned to us that they tried to build a voting app and it went online and they had like 1 million votes within like an hour and it brought down their system. So we tried to kind of make this thing foolproof. And the database, of course, that I mentioned earlier is that we're using DynamoDB. Now, DynamoDB is capable of trillions of operations per day, and it's actually one of the main databases that Amazon.com itself is run with. So we put together this GraphQL schema, or I'll put together this GraphQL schema. It has two main types, a poll type and a candidate type. And then we also added one custom mutation, which is basically a custom resolver for an upvote that returns a vote type. And there we have an ID and a client ID. Now, using this schema, I built this app called thisorthat.cloud. And this is pretty much just kind of like I mentioned earlier, a pretty basic voting app where you can create a new poll, a text or an image poll, and then you can kind of like share the link. So let's say I wanted to share this poll, paste it here, you can kind of do that. But the interesting thing about this is that we ran a script that sent in millions of votes per minute, and we were unable to break this. So like this thing will not break, at least based on in my experiences, which was pretty cool considering it didn't take very long to hook up. So like you can basically say, let's create a new poll is like, I can say, what is the better vacation spot, Croatia or Italy? And I might just call this vacation to make the URL really short. So I might be able to share this. So it's thisorthatcloud.cloud/vacation. So if you're watching this, you should be able to test this out. So if I open this up in a new window, you'll notice that this is actually real time also, which is pretty cool. So if I go over here and make an upvote, then I should see it come through over here, and so on and so forth. And when I tested this thing out with all of those millions of operations, we actually had the subscriptions working. So we had millions of updates also coming through on the client, which was kind of interesting. Anyway, so the code for this is actually open sourced on github.com/this/dabit3/thisorthat. And you can actually deploy this app by running a few steps and kind of test it out yourself. But let me go back now to our app and see if we can test this out, try this out one more time. Now that our app has been deployed, or our backend has been deployed, I'm going to try mocking this thing one more time. Yeah, there's something going on honestly with my machine. I think I might just have too much stuff running or something, because it doesn't seem to be pulling it up. But what I can do though is open up the API in the actual. Oops. Open up the API in the dashboard. We can test it out there. I think I need to sign in there real quick. So this is the dashboard for the API we just deployed. And we can actually run some operations here in the graphical editor. So the first mutation I might create is create a new post. Now, the first thing we might want to do is just create a post called like hello world. And we'll just return like an ID and a name. Now, the thing that with this though is it should fail because we have to be signed in as a user to create. Only people that are public can read. So this should fail. So let's go ahead and try this. And it says valid, unauthorized because we are not signed in. So what we can do now is create a user. And I'm going to go ahead and open up the identity management part of this and just create a user. So I'm going to go ahead and try to log in with this user. I need to get the client ID for this app. Right here. Oh, looks like I need to reset this password. Okay, so we're signed in. If we were mocking this, we should be able to like not have to do all this stuff, but unfortunately we're having to go this route. But now that I create a post, you're going to notice that I actually am able to do that now that I'm signed in as a user. And we can also get other metadata like the ID that is created on the server, even though we didn't actually generate those items in the mutation itself. The next thing we might want to do is query for list posts. So we should be able to query for a list of posts. And we should also be able to create a comment. Now, I created a comment on my own post, so I'm calling it like an awesome post. And the comment's successful, so I should now be able to query list posts again. But what I can do now is I can actually also get comments. And you're going to notice that we don't have any comments at the moment, because when we create a comment, we need to actually specify the ID for the post. So let's go ahead and take one of these post IDs and associate it with a comment. So now I'm creating that relationship between a comment and a post. So I can just say awesome post 2. And now when I query for the posts again, I should now have one comment for one of the posts. We're getting the posts and the comments, and then we have all of that in a single query. Now, if I sign out and sign in as a public user API key, I should still be able to query, but I should not be able to do anything else. So if I try to create a post or if I try to create even a comment, I'm unable to do that because I'm basically not signed in. So all of those authorization rules are working. All of that schema was generated. Even all of the relationships are all kind of working, and all of that's been already kind of built out for us pretty easily as far as the time that we had to kind of put it into it. What we're going to do, and if I have time after this, it looks like we're kind of running low on time. I might try to create a GraphQL resolver, which is for a Lambda function, which is pretty cool. So the last demo I want to show before I get to that is document collaboration. This is a pretty basic schema. So it's just a document type. So let me go ahead and make this a little bigger. Where we have an ID, we have a content title and created at properties, and then we have this client ID, which allows us to define who the person that is making that change, so we don't allow duplicate updates. So this app is running at this website here, writewithme.dev, and we're basically doing a little something similar to what we did in that example where we had the subscriptions going. So I'll call this new post. And I should be able to open this in a new window here and make some updates. And this is a Markdown editor, so you can actually write Markdown. You can even write code. And you can even add images and stuff like that. Oh, that image is not working for some reason. Oh, that image isn't even there anymore. So I guess I can go to my profile, grab this image, try that. It's not working. There we go. Anyway, and then I can go here and also make changes as well. So it's kind of like working on both sides. That's right with me. The last thing we might want to do is we might want to update our API to add a GraphQL resolver that interacts with the Lambda function. So to do that, I'm going to run amplify add function. And I'll call this function add function. Node.js is the runtime. We'll start with the hello world boilerplate. I don't want to access any other resources. I don't need any of this other stuff. So I've added this add function. And I spelled that wrong, but it's okay. What I want to do now is create a type of query, or it could be a mutation, either one. And I'm going to call this add. And add is going to take number 1. It's going to return an integer. What we can do is we can say at function, and then we'll say the name, and this is going to be, and then we can add, we can actually then add the environment if we'd like. So we can say the environment that we'd like to be working with, which is that dev environment that we would have created when we first generated this, or you can actually just use the environment name, which will automatically default to whatever your environment is. And then the last thing you might want to do is let's go into the actual function code itself. And what we want to do is we want to say, we want to take the 2 arguments that are basically going to be the number 1 and number 2, and then add them together. So what we can do is let's go ahead and delete this code here. We're going to create a variable called response that has the event arguments, number 1 and number 2. And then we just add those two numbers together, and then we save. And then the event basically is going to have a bunch of different properties in it. But the two properties that we're worried about are number 1 and number 2, which are going to be two numbers. Oh, these need to be integers. Actually, so intent. It's going to take those two numbers, and then we should be good to go. So I'll go ahead and deploy this by running amplify push. And then we're going to wait for this to run for a second and then test it out. While that's running, I'm going to go ahead and try mocking this one more time, just out of curiosity. I know we released a new version of our CLI a couple of days ago, so I'm wondering if they broke something. Looks like some people are voting. That's pretty cool. Yeah, I'm not sure what's going on with our local mocking, but it's not working today. But while this is deploying, our schema is going to basically be updated by the CLI. So we're looking at the schema that we have currently, which is all this stuff. It's quite a bit. And what we should now have is that additional mutation when this has been finished deploying. And this is actually the end of the talk, really. Once we test this out, so we're almost finished, because I know we're getting kind of close to being there on time. But I always think that this is a pretty fun demo using a Lambda function as a resolver, because people are more comfortable, I think, with working with Lambda functions. And this essentially allows you to kind of use GraphQL as that API gateway still, without having to have a bunch of separate HTTP endpoints. Instead of saying, okay, I need this one function to run like for this use case, and then having a completely separate URL for that, you can actually just create a little mutation or query, and then still have that without having to change a bunch of stuff. Oh, and then one other thing that I would keep an eye out for is we're actually adding support for Lambda layers. So if you've ever worked with Lambda before and you've needed to share dependencies across functions, you might have noticed that layers adds a lot of additional ease of use for that use case, and that Amplify did not support it up until recently. That's something that we're adding support for. So Lambda layer support coming really soon for Amplify.
Hello.
Hey.
We're done?
Almost done. I think I can go ahead and write out this last query here. So it's going to be query add. Delete these. Just waiting for this resource to finish updating. It's almost finished, I think. Yeah, I think because we're creating that new function, it's taking a little longer than if we were just making an update. Yeah, this is definitely taking a little longer than I thought, but I think it's almost done. Okay, there we go. Let me try to refresh this real quick. This needs to be a mutation. All right, let me try this out. Okay, I'm getting some error. I'm not going to worry about this. Oh, well, let me just change this to mutation and just give it one more shot. There's something going on with the code that I wrote, but essentially this is kind of the idea. You would just be able to add mutation, and I have some type of authorization stuff, I think, that is going on that's making this not work. But yeah, that's it for me.
Yeah, thanks for the talk. It's not just that you went over the theory part of the GraphQL and the method itself, that you even showed a demo, which is a huge plus for you. So, we're ready to move on to the QA?
Yeah.
So, we did manage to get a few questions, and the first one is coming from our colleague, actually, and he's also a front-end developer working with React recently, and when he was looking for a solution like GraphQL, he actually it's not connected to GraphQL, more like AVS type question. Like he was looking for a solution, and he found Google's Firebase, and he started working to that, and investing some time. So his question is basically, what is the advantage from moving from Firebase to AVS? Why would he switch, and how long would it take for him to switch?
I think Firebase and Amplify are very similar, and they occupy a similar space. Most of the people that move from Firebase to Amplify do so because they need a more scalable and more flexible data sources. Because I think with Firebase, the first class data source is Firestore, if I'm not mistaken. And when you're working with Firestore, you have that limited API feature set. But with when people move from Firebase to Amplify, they often do that because they want to use a NoSQL database. They also want to use maybe something like Postgres. They want to use something like Elasticsearch. And what you can do is basically set up all these different data sources behind your GraphQL API. And then therefore you're completely wide open as far as your data sources are concerned, and you're able to kind of implement different data sources for different types of features that you need. As far as like moving it over, so if you would like to move over from Firebase, I think it just depends on your the complexity of your app. If you have something pretty basic like just a database and some authentication, it should be kind of simple. If you have a bunch of functions and a bunch of databases and a bunch of different types of users, and they're in different types of like categories, like roles and stuff, something like that would be a little more complex.
So moving on, one question that came from chat. What do you think are the pros and cons of annotation-based development?
So the pros are it kind of abstracts away a lot of work that you would have to build from scratch. And then the con is that you are getting a lot of functionality that's been decided for you. It's very opinionated. And therefore, you're kind of going to be given implementation details based on our opinions and the examples that we've kind of worked with from customers. I would say the benefit though at that point is that everything is customizable. There are escape hatches for everything. So for instance, we create these GraphQL resolvers for you, but what you can then do is actually go in and write your own custom business logic in those resolvers, and therefore we're giving you, like, I would say these resolvers, yes, they're doing stuff like, I'm sorry, these directives, they're doing stuff like creating like your data source. But the main thing that I think they're doing is they're creating the resolver functionality that you can then modify. So you do have the option to go in and make your own updates.
And another question coming from Herman from chat as well. How do you interact with the generated GraphQL API other than from the client, for example, from a backend?
From the backend? Okay, yeah. Basically, there are a few different ways that you can interact with it. You can use one of our SDKs or our libraries, and we provide, I think, 3 different GraphQL libraries at this point. We have the main one, which, I'm sorry. I'm sorry, I got interrupted. Basically, yeah, we have 3 different libraries. One of them is Data Store, which is an offline SDK. One of them is the API category, which is kind of the main one. And then we also offer some abstraction on top of Apollo. So if you like the Apollo SDKs and client libraries, you can use those.
All right. Okay, 2 more questions, and then we are going to let you off the hook. Your probably mouth is really sour. How do you evolve the model after initial greenfield setup, for example, refactoring or database migrations or such?
So as far as evolving the model, you can then go back into your schema and make updates and run deployments. You can also take the resolvers that we create and write, again, like your own business logic. As far as migrations and versioning is concerned, we actually offer some tooling and documentation and stuff around how to do all that. If you go into the CLI documentation under GraphQL, you'll see a lot of guides and stuff that are there to kind of show you how to do that.
Okay, and the last one is more of a general question, which would be how much does a front-end developer needs to know about backend in order to use these platforms in general? So, I mean, in theory, you don't need to know a lot, but as soon as you try to create a scheme or a base or something, that doesn't make much correlations with front-end development, does it?
Yeah, I think the main thing, like when I started kind of digging into all this and having that experience, and then also fast forward 2.5 years now, I'm working with a lot of new developers. The main things I would try to understand are just how GraphQL operations work and how to model a GraphQL schema, because from there, again, most of that backend functionality is going to kind of be created for you. But let's say you did need some custom business logic. I think just understanding what the resolvers are doing and kind of understanding what's going on there is kind of the main thing I would probably dive into. But I think even for most new developers, you don't even have to go there. I think the number one thing, at least with AppSync and Amplify, as those are concerned, is understanding just how to model data in GraphQL. That's pretty much as simple as that.
Okay. Thank you, and thanks again for taking the time to display your talk to our community. I'm sure that they were really enjoying it. And before we sign off, anything else you'd like to add?
No, that's it. Thank you for having me. It's been fun so far.
Yeah, appreciate it, Nader. Thank you very much. And before we sign off, we are going to just mention that we got a new talk lined up for July, a bit over 3 weeks from now. We are going to have Debbie Levitt, who is going to talk about Dev and UX and how it improves efficiency and sanity for developers. So thanks for tuning in for yet another edition of TINEL, and see you next month.